Pre my talk, this is Seattle, which is aptly named by a 4-year-old. Seattle comes with me on trips, so everybody look like you're having fun. Okay. Anyway. Anyway, I am Jeff Lembeck. I'm an engineering manager at NPM. As was said, there's my Twitter handle. It's pretty easy to remember. You can come to there for the content about programming and management, and then stay for the neo-Dadaism appreciation, and be actively kind, or I just block you, like immediately. More unnecessary introduction, as mentioned, I'm from Seattle. This is actually the view from everybody's house in Seattle. I just took that picture before I left. It was very accurate at one point in the before time. You see, today I'm going to tell you a story. It's a story about a hero. Let's go. The world is veiled in darkness. Dependencies are inconsistent, builds are slow, version numbers matter not. The people wait, their only hope a prophecy. When dependency hell has plagued your JavaScript project, a tool will come. After a long journey, some programmers arrive, each holding a pretty loaded metaphor for a technical talk. I give to you Package Quest. Our story begins not long ago, our hero developer. You are given a mission to build a great website to honor your gods of user. Your gods are numerous and vengeful and will not tolerate an experience less than pristine. Your bosses, the masters of C Team, are demanding that you appease the gods quickly so they can be granted riches in this life and the next. This task sounds grueling. Building each piece of a website from nothing involves strong magic, patience, and time. And in a world when each of these items is scarce, we need something to help us, something to guide us, something to give us the pieces that leave us less exposed to the cruel, monstrous insects that anger our user gods. There is a place that is spoken of that was used long ago. After the great programming war, when the Dark Ages came into place, all of our help and hopes were destroyed. And speaking of this location, and the tool to get there was forbidden. But word of mouth is passed on from generation to generation, and you, our hero, will search out and find the land of our desire, the registry. The only thing we know is that to enter the registry, there is talk of a tool, a magical weapon to destroy dependency hell that was forged by sorceresses of colorful hair. This tool survived multiple iterations and was faster and more powerful than anybody could have imagined. This tool is called NPM. NPM was cleanly broken apart by the sorceresses, in case the day ever came where it was needed to be built again. I like keynote transitions, just get ready. Book 1, Chapter 1. According to old documentation found in the ruins of GitHub, our magical tool requires the help of 3 companions. Shishigami, the forest spirit, Pakoche, the master of packages, and registry client, a smuggler that can give you a special passcode to enter the registry. Each of these, when brought to the sorceresses of colorful hair, can be forged together by the light of JavaScript to create the NPM tool. And so, hero, to begin, we visit Shishigami, the creator of the Dependency Tree. The forest spirit's job is to piece together exactly what you need from your install. It scours through your list of package demands and also through what you have already installed and puts together an ideal tree, a perfect structure of your dependencies, so all your needs will be served. It achieves this by first reading your local package tree. It does this by combing through your node modules folder. Then, it reads your package lock JSON to make sure that the tree built from your node modules directory matches the tree from your package lock. After that, it is time to get the metadata for each missing package. At this point, Shishigami will call upon Pakoche, Pacoche's role within building a dependency tree is to reach out to the registry to get information about each package needed to be installed. According to the documented scriptures of Pacoche, this information will be delivered via corgi doc, which is not a small and cute dog, as pictured here, and also an excellent thing to show up in a Google search if you're looking for corgi doc. Okay. But a very small piece of metadata that lets the tree worker know which versions of the package are available in the registry. Once the metadata is in place, the tree is normalized. Shishigami then puts together the ideal tree and calculates the difference between that and the tree that has been put together from the package lock and the metadata. This difference is where the packages are moved, removed, or fetched and installed. Shishigami is located within the npm repository, now at github.com/npm/CLI. You go there and speak its name. It joins your party. Book 1, Chapter 2. Now that you have Shishigami, you will need Pacoche. Pacoche is the master of packages and comes equipped with her own caching system, Kakash. Waiting for a Spanish speaker every time there. Kakash is Pacoche's nearly endless pack of fun. It is a key value storage system written in Node.js that is immensely fast. What it does best is get you the correct data quickly. It does this with great concurrency, incredible fault tolerance, support for SHA-512, for integrity checks, and data consistency that notices if its data is corrupted. During installation with the npm tool, Kakash stores the package data on disk. There. If the content is unavailable in the cache, Pacoche uses makeFetchHappen to fetch the package. MakeFetchHappen is a wrapper for NodeFetch that tacks on HTTP cache support, request pooling, and several more features to make it very easy to use and very fast. Its caching system relies upon Kakash. And because Pacoche knows that MakeFetchHappen uses Kakash as its caching system, when Pacoche is asked to fetch a package, it can use Kakash directly to get any data that it would use MakeFetchHappen to request before it uses MakeFetchHappen to get the package. A lot of times to say MakeFetchHappen. So, first it asks Kakash, do you know about the package I need? Many times Kakash says yes, but when it says no, Pacoche can use MakeFetchHappen to go out and grab the package. Then when MakeFetchHappen returns the package, it can be stored back inside of Kakash for Pacoche to get next time. So then if you're on another project and you install that, it'll just pull from disk. Pacoche also provides an extractor in order to unwrap the packages that it is installing. Packages come from the registry in the form of tarball, and Pacoche understands how to make this into executable JavaScript for your consumption by unpacking the contents and placing that accordingly. And as mentioned before, when dealing with Shishigami, Pacoche is capable of reaching out to the registry to grab the necessary metadata to understand just what packages you need. That metadata helps Shishigami by letting it know which versions the registry has and of the packages you need so it can build the dependency tree perfectly. Pacoche is largely the workhorse of the npm tool and lives in a repository on GitHub, where you'll find her. You ask, she eagerly joins your party. Book 1, Chapter 3. The last and final spirit you need to build the tool is Registry Client. The registry client is a wrapper around the npm registry's external API, and so she provides these abilities. These abilities include changing ownership of packages, publishing and unpublishing packages, adding and removing members to and from your orgs and teams, and she even provides authentication. You find Registry Client lurking behind a corner on GitHub. You pass it a note saying, "Will you join my party?" It nods its head and follows you. Book 1, Chapter 4. Pacoche, Shishigami, and the Registry Client have guided you to NPM Inc., home of the sorceresses of brightly colored hair. They introduce themselves and walk you and your new party members to the installer. Within the realms of the installer, they forge together the spirits of your party members to be called upon anytime you desire. Their magic is strong, and they have added to the tool the ability to increase its level, to learn new skills and talents along the way, while simultaneously making the quest to obtain your packages smoother. You can do this by telling the tool to install itself. Right now, you will get version 6.2. This has functionality like npm audit to keep your application secure, lightning fast installs because it just gets faster with every major, new and improved npm init, and many other things. CLI, 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 they chant. The tool is yours. Go, log in, and install. Book 2, Chapter 1. With the mission to forge the CLI complete, With the mission to forge the CLI complete, we turn to our map to see the path where the path forward leads. All signs point to the great registry. Let us make the journey. You start your quest at the land of Terminal Point. First, we log in. You pull out your CLI tool. You speak into it. npm login. The spirit of the registry client emerges. Username. J. Lembeck. Password. A very good password, probably not that one at all. Up to 64 characters, random amounts of letters and numbers and symbols, generated so you don't know it, one use, you get the picture. Email, jeff@npmjs.com. Authenticator provided OTP. Seriously, turn on 2FA. Do it today. Pull out your app and do the number thing and go, okay, yeah. And with that, you're whisked away. We ride the road of the great network to the first destination on this request, the shopkeep. She goes by the name of Cloudflare. She and her sisters, all with the same name and same personality, just different locations across the globe, like Officer Jenny or Nurse Joy, spread the globe and position themselves in ways so you'll get to them far more quickly than if you were to reach out to just one part of the world. She handles the cache for packages, and if you approach her with the name of the package you're looking for, she will do her best to get it for you. Unbeknownst to many, Cloudflare also provides traffic routing. She handles all requests to the registry and will forward them along to where they need to go. How she does her work is largely based on her caching abilities in a router layer written in JavaScript. Side note, Cloudflare's all the scripting with it is done in JavaScript, and they use the Service Worker API, which is really cool because you already know how to do it most of the time. Anyway. Cloudflare looks at you. What brings you here? Authentication? Oh, let me see, right this way. Cloudflare guides you to a path. Ahead lies front door. Go. You are whisked away to the next destination. Book 2, Chapter 2. Front door operates as the entry point to the NPM registry. Information about packages, users, orgs, teams, and any modification to those things must first go through front door. Front door also handles the path to authentication. You and the registry client knock on the doors. From behind the walls you hear, "What is your purpose?" "I'd like to log in." "Hand me your credentials." One moment. The guard behind the door calls for a messenger, the npm auth WS client, and tells them to take this information and be on their way. Chapter 3. npm auth WS is a gatekeeper for proving who you are and where you can go. She is quiet and only speaks with messengers from behind the doors of the front door. npm auth WS will be handling your authentication. Authentication being when you prove who you are. This is versus authorization being when you check to see if you have access to something, so stop naming things just auth. That was out of character, I'm sorry. To check whether you're authenticated, npm auth WS will reach out to user ACL2 to log in. To check whether user ACL2 is the grand beholder of truth. If any changes are made to any accounts, it is written by user ACL2. And then that information is sent elsewhere via messaging. Any of the calls to front door from the registry client that might involve changing teams, organizations, package permissions, or users, user ACL2. And most relevant for this story, logging in happens to also happen in user ACL2. Upon login success, user ACL2 produces a token and hands it back to npm auth ws. Then npm auth ws stores that token into Redis, the great dictionary of keys and values. It will use this token in any instance where you need to access the registry again. Once it has done that, it passes the token back to front door. The door is open and a hand slips out with the token attached. Registry client takes it, walks back to you, grabs your hand, and you transport back to Cloudflare and then back to terminal point. Your token is written in your npm-rc file. You are now logged in. Read chapter 1. Now that you are logged in, it's time to install. You look around and you are surrounded by nothing. Terminal point is empty with the exception of you in the CLI. Your mouth starts making a sound like it had made 1,000 times before. npm init -- yes. You're not sure where that came from or where you'd heard it, if you'd ever heard it, but there it was, being useful. And now in front of you is a package.json file. You look at the CLI once again and say, npm install npm/spife. It's a heck of a web framework. Shishigami arrives and looks around, seeing no node modules folder and no package lock JSON. Shishigami whistles and Pacoche arrives, carrying Kakash over her, over her shoulder, or in her hand. Like in this picture. They speak quietly. They put together the address. Pacoche grabs your hand and you disappear again, back to Cloudflare. Once again, you walk up to the shopkeep. Pacoche speaks. Hey, check the address. I see you're here for the corgi of a scoped package. We must first see if it's public. Before you can say anything else, she opens the door and calls her friend PackageViz API. Had the package been unscoped, by default, it is public, and we could skip asking. Before you can say anything else, she opens the door and calls her friend. There we are. Damn it. That's what happens when you cut slides beforehand. PackageViz API exists for one purpose, telling the caller if a scoped package is public or private. And if public, PackageViz instructs Cloudflare to retrieve the package directly from S3. If it's private, PackageViz tells Cloudflare to send the request to front door. PackageViz API assures her that the package is public. Cloudflare sends you to a specific address in the Cave of Wonders. And you arrive at the Cave of Wonders, an S3 bucket that is the home of packages and their information. Here, ready for your corgi. You remember from before, that a corgi is a metadata file for the package requested. It's significantly smaller than your standard JSON representation of the package, and it includes disk tags, version numbers, and each version's dependencies. Who disturbs my... Oh, hello, what do you need? We're here for the corgi of this package. Here's the address. Very well, go right along. You go get your corgi. And take it back to Cloudflare, who then caches it for quicker retrieval the next time it is needed. After that, you head back to terminal point. Once arriving, you and Pacoche hand over the corgi doc to Shishigami, who reads it and then sends the two of you back for the corgi of each dependency. This occurs until all of the corgi docs are retrieved. Once Shishigami has all of the docs necessary, it produces a dependency tree. You've gained your dependency tree. Now that you have your dependency tree, the tool begins glowing again. It calls upon Pacoche to get the packages. Pacoche sees the versions and packages needed and uses those to create new routes to request. This time, it's tarballs. Pacoche checks inside of her bag. It's empty. If it had had the file necessary inside the cache, it'd be copied over to your node modules folder and you wouldn't even need a download. It's really built to be that fast. But she pulls out Make Fetch Happen, grabs your hand, and once again, you're on the road to Cloudflare. And it just so happens that tarballs are Cloudflare's specialty. Exciting. Pacoche walks up to Cloudflare. It says here that I need to reach this address. Oh, let me see if it's in my cache. It is. Here you are. Thanks. And you're on your way back. That was fast. Had she not had the package, she would have sent you along to S3 to retrieve the package, where she would then cache it upon getting it back. Cloudflare's caching system stores cacheable tarballs at its points all across the globe, all the public packages. This means that public packages have been this means that if a public package has been downloaded by even another user near one of those points, it'll be cached there. This makes for a really quick experience. Pacoche's make fetch happen stores the package away for you in Cache, just in case you need it again. This continues through all of these packages. Pacoche checks Cache, does not have the necessary package. Heads to Cloudflare, she either has the package or not. If not, she sends you to the closest S3 instance and makes sure to cache the package on your way back. Once each of the packages has been downloaded, Pacoche begins the extraction. The tarballs are untarred and placed in the node modules directory to match the tree. The tool glows again and begins to run its lifecycle scripts. You hear a song sing the words, pre-install, build, install, post-install, finalize, refresh package JSON. Your package JSON has changed. All of your files are properly placed and built, and they are now requirable from your project, and you can use them. And over. It'll be real quick to launch, I promise. All things are peaceful again. You can move quickly and build your web application now that you have a framework in place. But you need another package, and this time it's a private one for your org. You pull out your trusty CLI and speak into it. npm install at fantasyworld/supersecretcode. Shishigami arises again and calls upon Pacoche for you to go get the corgi for your scoped package. You and Pacoche head off to Cloudflare. Cloudflare asks what you are here for and notices that your corgi doc request is for a scoped package. In this case, PackageViz informs Cloudflare that the package you are looking for is private. Back to front door with you. Once you've arrived at front door, npm auth ws is there to greet you again, this time to make sure you are who you say you are. How again does she check that? Remember logging in? When your token was created, it was stored in a Redis instance that is now being referenced by npm auth ws. As long as that token remains in Redis, it is valid to reference and can be used to get through npm auth ws. So any tokens that you've created are available if you go to that URL. We won't display the whole token, and you likely right now don't have very many of them. Once npm auth ws grabs that token, they authenticate that you are who you say you are. Then they head to find out that if you have access to that package that you seek. In order to get this information, npm auth ws checks with the keeper of user authorization data, user auth cache. Chapter 3. User auth cache serves a very specific purpose. Does this user have access to this package? If so, is it read or write access? If it does not know, it reaches out to user ACL2 to find out. As I mentioned earlier, user ACL2 is the true master of knowledge. It holds the final say on all things. In its checks to see if somebody has access to a package, it also consults its trusted advisor, Payments API, who you can see here has sweet jewels. Payments API makes sure you're up to date on payments. It's basically, it's almost a proxy DB for Stripe. Since any writes in our system go through to user ACL2 first, once the package and user relationship is cached, if anything happens that can affect the relationship, user ACL2 invalidates the cache value in user auth cache and simultaneously invalidates any caching of the document in Cloudflare. Today, the sun shines upon you. Nothing has been invalidated in the wrong way. npm auth ws returns with news from the user auth cache. You are allowed. Proceed back to Cloudflare with your head held high. Had user auth cache returned with bad news from npm auth ws, you would have received the mark of forbidden. Now that you have permission from npm auth ws, you return to Cloudflare with new credentials. She checks her cache to see if there's an entry with this package. It's not there. She opens the door to the path of Cave of Wonders. You go get that fuzzy little doctor. Yeah. She caches the package in such a way that only you can retrieve it. You go back to terminal point. You've got the hang of this. You have the metadata, you have the tool of valor, you know the path. Join Pacoche and follow the same route to get your packages. With your bravery, hero, you've once again opened the doors to the promised land of the NPM registry. Now the 10 million voices that call out for hope once again can appease their gods and their masters. That is, until you overthrow both. Thank you.